Do we need landfills? As soon as we had our European Landfill Directive in force, we, based on that, we created our own landfill law. And this figure is from the first waste management plan in Estonia. It tells that we have about this amount of waste, and the organic content of the waste is the green line. This much. And we knew that we have certain checkpoints that the number of the amount of organic content should be reduced. Then the deadline was here, here, and here. And the most logic thing for the lawmakers was to draw a line. Let us do step by step. We are here now. So what happened? It's very educational. Did it go like this? After the first deadline passed, the result was actually this. Nothing happened. So we removed a little bit of paper and timber from waste that goes to the landfill, and that's it. No biotreatment still. But things started to happen. Here was a deadline where all old landfills were closed by force. By this time, 2009, every single old-style landfill was closed. Transportation is longer. Then we started to increase the landfill tax. Slowly. It was below €1, 1, 2, 3, 5, 10, 12. Now it is 30. From 2015, it is €30 per each ton. What does it tell you? Expensive to take everything to the landfill. Then we had another deadline. Shortly before the landfills were closed, it was in the law that no mixed waste or no unsorted waste was accepted in landfills. Okay, it was allowed, but then you should pay 3 times more. So the gate fee, about €60, you don't sort, you pay 3 times more. And then you transport long distances because landfills are closed. Doesn't make sense. So this is how to educate waste companies. The language is money. They did some calculations. Transportation is long. The landfill tax is huge. Sorting is anyway required, so we don't put waste in a landfill. But what happened here? Still no big progress. In early 2010, 2011, the only cement industry that we have in Estonia, they invested into feeding line of solid recovered fuels to the cement kilns, which means that the cement industry, which is very energy demanding industry, they decided to reduce intake of fossil fuels and replace it by alternative fuels. And cement industry was talking to waste companies, and they were teaching each other. Cement industry as a customer, they have requirements, and waste companies made test trials. Then they came together, that's not good, how to fix it, okay, another trial. So they worked together. Since there was a customer, the cement industry, the waste, 2 of the biggest waste companies, they decided to invest into the factory. And then we built 2 large factories to produce solid recovered fuels. And this was the point where I noticed that, yes, the amount of waste that we put in a landfill is decreasing. But waste business is a big game. One is winning something, the other is jealous, so they invest into something similar. And then the governmental energy company invested into mass burn facility. And we started to burn waste in Tallinn. In 2013 it was opened, and then it was very fast and very deep reduction of waste that we put in a landfill. Very positive. Kind of very positive. Back to that soon. What we face now is that the European Union has decided to go for circular economy, which in a language of sentences means that we will have new rules, and the rules say that we have binding reduction targets. Binding means you must do it. We have stricter requirements, which means that everything is better controlled, better documented, better reported. We have strict methods and rules how to calculate the progress so that there is less hocus pocus in paperwork, which unfortunately is still there. And we need more circular everything. So if you open the statistics here in Estonia, you see the landfill and you see the recycling figures. The landfill figure, disposal, tells us that it is reducing very fast because we have mass burn facility, we have waste to energy, we have composting in place, we have waste collection and sorting in place, so it has to reduce. It's expensive, that's why we don't put waste in a landfill. And we call it well done. Recycling and recovery is increasing, and you can see it as perfect. But during last few years, I see alarming increase in landfill statistics. Maybe 2 last years, we disposed less than 10% of all the municipal waste, which is good. And now we dispose 20. And what's the reason? The incinerator is dominating a lot. And since incineration is expensive, they have a gate fee. And before, it was fixed price for all, just bring. Now they make auction, tendering. Who pays more will get exclusive right to bring certain amount of waste, which means others don't get nothing. This may happen if you have only one very large scale waste facility, which is not a very good message. How we look among other countries. Here is many countries in the list, and packaging recycling is the yellow, composting biotreatment is green, incineration is red, and landfill is black. And you see that in some countries you do not have landfills anymore. They are not necessary. And in some countries everything is still put in a landfill. Countries that don't require landfills are either German-speaking countries, Benelux, or Nordic. And sometimes countries that are in trouble like Singapore, they don't have space. Some countries have still landfill-based, but what happened to Estonia? I have 2 Estonians here. One before incinerator and the other after incinerator. And you see that before incinerator we were not so good. And after incinerator, the share of disposed waste has decreased to minimum. So we see in the future less disposal. We see packaging recycling in place, nice, some biotreatment, and we see lots of incineration as a big picture. Now we should compare it with the target values. And the target value right now is called 50-50. We have a social agreement that 50% we need to recycle and 50% we can dispose in a landfill or incinerate. You see that some countries exactly do it. They have achieved it. And some countries do even more. Nice. So we can put it in a list, yes and no. Yes list is here and no is there. But if we put a circular economy target here, then you see that none of the countries in Europe or globally can achieve it, even not the rich countries. Not that it's not technically possible, it is. It's the way of thinking, it's economy, mostly economy. To achieve the targets of circular economy, the only option is to get rid of landfilling, close to zero. To reduce incineration and to increase biotreatment. I travel a lot and I see waste management in other countries, and if I try to explain what I am proud of here in Estonia, then I would say so. The first thing is you guys. What Estonia can offer to the world, this is you. Because there is no other such movement, such powerful and nice. The technology to make some goods out of mixed plastic waste. Later on we will touch the waste and we'll try to see if it is possible to have plastic materials separately or not. Then this is the technology that we have invented here in Estonia to produce goods from mixed, very low-grade plastic material. So this is input and this is output. You can upgrade the quality too. So would you allow this item in your house? About solid waste management. It's written in textbook until today that this is not possible. So this material, instead of going every single piece by piece, trying to identify what is the material, you can turn it into that. It smells a little bit plastic. We use it in outdoor appliances. To get this done, you need a two-stage process. First, you take mixed plastic waste and you turn it into intermediate product. This I would call downcycling. And from this product, you produce this. So it's a mixed plastic agglomeration, semi-final product in your storage. And then you take this intermediate product into the typical plastic factory where you have a little bit of secrets involved, and then you produce planks and maybe goods out of it. Very nice project. We had a full-scale landfill mining here in Estonia, where we took a landfill like this, we excavated it, separated into different materials, upgraded the landfill into a public park, and with material we experimented. We were heating Tallinn during 1 day. We take some waste fuel to cement industry. We produced the same plank to see if it is possible, and it was. And we also produced some oil out of mixed plastic, just to irritate oil industry. And the last one is that we should be able to market waste-derived products. And now we are back to your question, is it safe? To understand is it safe, we need to have a system that can confirm that or study that. And it has to be economic too. So we have created a national certification system in Estonia, which is well done, because now we have the body that can compare the parameters that you have with the legally accepted values. So why was this development possible? Because we learned, the knowledge has increased. Also private, also authority, also the academia. We know more because we learn from each other. We have a cluster, we travel together, we see what others are doing. We have law in place, European law in place, and it works. Price of raw materials has increased, so you can sell materials. Market for waste products has increased, so you can sell materials that you make from waste. Polluter pays principle is in force, which means it offers funding for collection. And the investments, European and local national investments, plus a little bit private investments. And of course, you need some overcapacity that we already have to reduce the price. And of course, you need innovative thinking. And ignore the statement, already my grandfather tried it. Transboundary shipment is not easy. If the waste is not sorted, not treated, then it is not allowed. If it is sorted and treated, even if it is badly sorted, then it is possible.
What does it mean that we are lacking waste? Is it like because of the incinerator?
Because of the incinerator. You need to run incinerator non-stop, day and night. You need to have a certain amount of waste per day. And if we give them all the waste, there is no space for recycling. If we recycle, they don't have enough waste to burn. So we take waste from Finland, for instance. We bring it from UK and Ireland. So why is so that there is cash and we don't want it, and it's still in a landfill? What's the reason? It is cash, and still in a, what is the best motivator? Cash is a good motivator. Still they throw away cash. What went wrong? High price of the alternative, maybe, or lack of alternative. There is no alternative, no whatsoever. Or this is a market issue that no one wants to buy it, or is it attitude and ignorance? I don't care. Waste is ugly, so we throw away. So I think firsthand we have to fight against the attitude. And the point with this picture is that it is taken from Tartu landfill maybe 15 years ago. And it was not possible to drive to the landfill other than passing the company who offered cash for waste paper. And this truck did not stop that. Did not want cash, but he wanted to pay. So something is wrong in our head. What would you produce from this paper? New paper. Easy guess, yes, new paper. What else? But it's also heat, you can burn it, get energy out of it. You can produce insulation materials. You can make a construction material like planks or something. It is possible. Or you can make biogas, or use maybe nutrients, CNP, that is possibly that. Or you can make art, which is per kilo the most expensive. But you don't sell all global paper as art, of course. So many options. So select one.
But for heat and energy, even the bad quality would go.
Yes, of course. But now you select one. You have this heap, select one. What's the basis of selection?
Upcycling is better than downcycling.
But what if the quality is not so?
Market.
But what if there is no market? So how do we make a decision? Businessman would say, okay, let us burn everything, because in 5 minutes, problem solved, everything is burnt, maybe we take some energy too. So the idea is that we should rank those methods based on what is beneficial for nature and not for a businessman. In best case scenario, they coincide nicely. But we call it waste management hierarchy. And you see there are two hierarchies. Usually we say on top of the pyramid, that's the king. So the best is to minimize and avoid, because some of this paper was fully avoidable. Then we try to reuse and prepare for reuse. Then we try to recycle as material. Then we try to take nutrients or gas out of it. If not, then we burn, and the last option is that we put it in a landfill. So the base of the pyramid is bad and top is good. And the other pyramid this way means that largest by volume should be reused, recycled, less for biotreatment, less for energy, and nearly none for disposal. Today we put a line here so that you can burn for energy half of it. And the other half you should try to recycle as material, so that the material does not leave the material cycle. And this same logics is about every single waste material. And now we need to touch the waste materials so that we feel the quality, we have some inspiration, what can be done from this material. And I have prepared a table full of materials. And I need that you do some teamwork. And you pick from the table and put on your table materials. Who is taking paper? Okay, gentlemen, taking paper. Who is taking this plastic? Then we have PVC, LDPE, PP. Other types. A category called glass. Composite materials, which means many materials combined. Then we have aluminium, and then we have ferrous metals. And then we have maybe wood timber. And then we take hazardous materials. Who is the hazardous person? So, stand up, take your fraction, put on your table.
Nad ei tahtnud mingil põhjusel, ei seal, aga paber oli neil.
So waste is confusing us, but let us see what story waste is telling. Glass has material, waste or resource. What do you have on table? Easy to pick, very good. Everyone can recognize without any knowledge. 2 glass bottles here. Why not?
Because they look like plastic?
No, they are plastic. For people, do you think they make any difference? It's glass. Then you have the foil. Is it big issue? Very, very high temperature between electrodes. And if you have metal, you will kill the oven. Do you see any difference?
Weight versus material. The lighter?
Yes. Why? It's one way bottle. You throw away. This you circulate inside your deposit system. Yes. This you wash. How do you know that? Because you see this and this. What is that? Glass with a costume. So it's easy to sell. They are so proud to sell costume glass, but for recycling people, it's a nightmare. Yeah. And this is glass. It's foamy glass. It's very light. It swims on water. Nice. It's a decoration glass. Why not? What do we do with sharp glass? Huh? It's actually a fragment of a floor. I picked from Sweden. It's decorative. It's nice. You pay money to walk on it. If you ask. If not, then you will say, "Oh, there is glass on the floor. Remove it." The storyteller. Of course, you need to take care of safety because it's processed so that it's not sharp. But the idea is good. Why not? And then you have a glass sand. Part of the water purification system. Instead of sand filter, we use glass filter. It's nice, new, innovative. Why not? But most of the bottles are not glass anymore, but plastic. So we produce those bottles from the baby bottles, always on site. When you fill those bottles, you blow it, heat it, you blow it, and then we have a paper here and another type. What is that? PP, PE, PVC. Complicated. Why so many colors? It's a pure marketing. So many nice colors. Cool. To sell it, but to recycle. It would be so easy to recycle one color only, to reduce maybe a tax for transparent close to zero and tax heavily those would be nice. There are some bottles which are special. What's the difference? About 5 times weight difference. You fill it again. The same bottle as this. You wash it and fill it. You see the lines here, which is an indication that it's scratched a lot. Here we sell this kind of bottle in Estonia, and in US, in many Eastern countries, you see this kind. It's very light, super light. Why it is so light? It is so light because we told them, make it so light, save material, and they did. Just a second.
I see.
So, I don't know if it smells, so we open it a little bit later. This is made of this, and this is a fiber that you can use for textile production. Maybe this one. Yes. This is PET bottles. So you need to understand what is the cycle or the chain of actions. First we need to collect it separately, then we need to get the intermediate product, and from this we need to get a marketable product. And then you do good. Until someone opens another part of discussion about microplastics. Right? How do I understand that this is PET? That is a sign. Number 1, right? Materials look similar because it's the same black. Right? Same black, shiny black, because it's yellow. It must be the same material, right? But there is even easier option. If you watch here, then you see that there is a dot and there is a line. So it's like, this has a line, which means they make 2 of them and they put them together. There are such indications which help you sorting. So PET is not always transparent. It can be totally black too. And here, there is a line. It's not PET. And this is dots.
I have this shit here.
What is this? Yes, and this is one of those problem plastics. Because if you start shredding it, it will like waste recycling people, they don't like it. It's not so difficult to cut it. What is this?
Something shiny and nice.
Shiny, very professional. Kitchen plastic, where I fry my chicken in it. So you put it in the oven, it doesn't melt. So it's totally different type. 7. Other. Here is a typical example of number 7. Plastic types. This is it, forgot to say. And why it is number 7 is this thing.
Yeah.
Because it's different plastic. This number 7 and it's written other. Very nice. Maybe because it's one type, the etiquette the other type, and cork third type. So you could also put the other. This I would classify as composite. Who have composites? And this is composite. The Tetra Pak is mostly this paper. But since it has also plastic, aluminium, and also the lid here, we call it composite. So what is this? I'll show you from this gentleman. This is this. Why does it look like this? Because it's a transportation issue. It is big. It's 17 grams. It weighs nothing. And if you transport it, you transport air. What type of it?
Maybe aluminium.
You think so? Yeah. Maybe not so aluminium. Yes, it's a steel. This is the aluminium with a magnet. Yeah. And they make it even more complicated. This is, but this is not. If we take take out every material that we can name as packaging material. From this particular heap, we got 16%. Packaging is something that is in our society wanted very much, because this is packaging, this all is packaging. And it looks so good because we already know what we can do with it. Let us make this from the packaging, let us make the textile from that, and maybe... So you have an end product that you can easily understand. If I modify this differently, I get material that burns. And this is 80% and more. So why worry? Let us burn everything. We know that burning is waste of resources because material leaves the cycle. So if I combine it yet differently, get out biodegradable material, then you see that we have 80% biodegradable. So the deal right now is that we should incinerate half, but we incinerate more. Instead of incinerating massively, compost this, save nutrients. And this fraction that gives us very low quality compost, then we better incinerate, maybe like that. You should open always your waste bin or heap, whatever point in the world, and look what is inside. Try to find a place for this and this and this and this material, and what's the rest you calculate. Is it burning, or is it biodegradable, or is it inert, and we use it as aggregates maybe. There is a lot of organic material, but it contains everything. This is very clearly food. So packaging is nice, beautiful, if it is before consumption. Brilliant. After collection, it looks already a little bit more messy, like the one on your table. After collection, mixed, dirty, ugly, smelly. Individual materials are difficult to sort. Recognize the materials. And this exercise was to confuse you. And this is helping us. The sign sometimes tells. We have the same sign about every plastic type. There are way more plastic types, but in our kitchen we find 6, and the 7 is all the rest. In other countries, of course, the sign is different. We put here PET or 1 or 01. It's exactly the same, and the message is, it is characterizing what is the material. And then we have tricky materials. Number 8. What is that? Maybe you know. But PP is not 8. Yeah, this is 8 and this is PP. Because the answer is here. Do you see the answer? They have learned you can sell plastic packaging in Europe only if you have a sign. So they put a sign. So you see more signs. European standard, good, nice. What is this? You can sell in the Russian market, yes, Russian. Keep country clean. Food quality. Yes. What is this?
Something the Germans came up with.
Yes. It's a producer responsibility issue, which tells that the producer has joined the producer responsibility system. They have paid to collect it back. And then this is PET. This is common for all countries, or at least valid in European Union. The recycling of individual plastic types is nice if it is put like this. Usually we try to produce non-food products out of this material. Outdoor furniture, for instance. What do? We bale the waste, we make flakes, and from the flakes we make granules. This you can sell, it has a price, this has a better price, and this has even better price. You see many such products already on sale. Mixed plastic is different because different plastic types don't mix. They harden and then they make very unpleasant. We have made this in Estonia. Good. Be proud of it. And the reason why do I show it is that if we clean the country by country in September, we get this. In many cases, this plastic that we get is already washed by sea or by rain, so it should be handled as mixed plastic. And it is technically I hope that also logistically possible, that we produce such. So maybe we should try to separate waste from some of those favorite countries that we get this, ship it here or produce such aggregates, and then try to produce this. When we did landfill mining, we built a plastic washing machine. To understand how does it work, I called to electrons, because they build washing machines. What do you think? What did they tell me? I want to build a washing machine for waste. Volume 1 ton in 10 minutes.
Go burning.
What happened? What did they tell me? They started to design a washing machine immediately. So we built a washing machine. I can show you the pictures. If you need, then you wash it. The quality gets better, much better, and the water is dirty. But since we are from the water department, then we ended up in having 2 theses. It's possible. So I am optimistic here. One option to understand or differentiate plastic types is to watch it in disco lights. And some of the bottles starts to shine. With a UV light, for instance, it shows different picture. It is a paper sheet, the bottom of the sheet and the top of the sheet. So paper is made of fibers. And this is to demonstrate you how easy or difficult it is to recycle. We zoom it, we get this picture. Those are the paper fibers. This is one fiber, this is the other fiber. And they are like hairy. And the hairy is keeping the fibers together. And now if you recycle, you need to separate the fibers. And you don't separate it here. You separate like this, you cut the fibers. That's why they get smaller and smaller until you can't recycle anymore. Okay, also the paper sometimes you contain such a sign and the identification code. 8 times they say it's possible to recycle paper, and they say that best results gives you just 4 times. So paper is to postpone cutting trees, not to avoid. What type of aluminium do we expect? We expect cans and foils. Steel cans. They look nice, they are steel, but they are tin plated. So to recycle it, you have to remove this tin. Those cans, they take it in, they shred it into fine particles. Then you run it through the magnet. You pick out all ferrous, and what is not picked is aluminium. So basically you take in those tins and you get out metal and tin plate. We didn't talk much about timber. So it's energy or sometimes compost if it's clean. What do we do with textile? Post-consumer textile is not solved at all, because all the textile material, they're mixed. If it's pure cotton or natural fiber, then it's easy. Usually it's mixed, it has buttons, it has zippers, everything, so it's difficult. And there is no good solution. Difficult means, looks like, sounds like a thesis project. Yes. Shoes.
It's even more difficult.
Even more difficult, yes. We produce a lot of unnecessary footwear. How many you have at home? Glass, of course. Typically we have 3 types, 3 colors. In some countries we collect glass by color. It's possible to separate colors by machines, because we have developed optical sorting systems that give good results. So in some countries we collect by color. Here we collect everything mixed, and then we take it to the sorting facility in Järvakandi, and then we sort out the transparent. And we do not want ceramics typically, and we don't want crystal. Window glass, flat glass is trouble, because it comes with frames. Sometimes glass is laminated, it has metal inside, a net, plastic. It's difficult. I love the idea of making those. Just that you need to shred it, and if you put some illumination underneath, it's lovely. Or you put it into the paints. Then we have a material or items that we call product of concern. For instance, this is containing batteries. And battery is containing maybe nickel or cadmium. If we remove batteries, it's already better, but still has a microchip inside. It's a difficult type of waste. If I throw it away today, out in the forest, by evening it generates no health issue, but it may produce such a health issue after a while. And they require special handling. And typically it is equipment, the cars, car parts and vehicles. It's electric and electronic, tires, and for instance agricultural plastic in some countries, also in Estonia. And we collect it, and producer pays principle applies. We have a list of compounds that we don't want to have in our everyday life. And what are those compounds? They are lead, mercury from lamps, cadmium, chrome 6, and biphenyls and diphenyleters. And then we play a game called Prof's Directive in Waste Electric and Electronic Equipment Directive. And then the producers put a label on their product, like Prof's compliant, no lead in that equipment, which is kind of advertising. Buy my stuff because I was good. And we hope that the customer makes a wise decision in a supermarket. Waste Electronic Equipment Directive. We want that it should be ROHS compliant, and they are all products of concern too. The aim of this directive is to give a possibility for people to return this electric stuff, and you will find such sign. The old equipment, we don't know who's the producer, whom to give a bill. But here I know exactly, it goes to Mr. Epson. We have made agreement 2005. Before that, we act differently. After that, we know exactly how much we put on the market. We sell computers, like we sell Dell, and we sell Lenovo, and we sell Apple. They are all one segment. They are all called computers. Recycling and collection cost money. And now the waste company, whom to sell the bill? To Apple or Dell or Lenovo. And then they look the market share. 50% is Dell and 30% is Apple. And then we take also the very old electric equipment from companies that don't even exist anymore, from 60s. We can't sell a bill for them. We sell half of the bill to Dell, 50% according to market share, and 30% to Apple. This is to manage the cash flow. We have 10 categories of waste electronic appliances. Large equipment like maybe refrigerators, small like headphones, ET, consumer equipment, irons, lighting equipment like those lamps. And then we need to take it into parts. It's a manual and combination of manual and mechanical work. First we need to collect it, it costs money, and then we need to dismantle it, it costs money. Refrigerators contain freon, so we need to empty the refrigerator and take out all liquids. Collection system is for free, here at least. Freon R12 was the bad one. Mm-hmm. It is safe for people, bad for ozone layer. Mm-hmm. So we have decided to ban it, and now we use other type of liquids, which may be not so dangerous anymore. Mm-hmm. But we still prefer to process the same way, just to keep it as a habit. Mm-hmm. It's the same with batteries. Very often it's written, no cadmium, no nickel, no nothing inside. You believe that, yes? So some say, then it's safe. So why worry? Why should you keep this battery recycling system alive if there is no need? It is typical that it is educational purposes, so that we don't forget habits. Car. What do we do with cars? Shredding is easy. Technically, it's very easy to shred a car. What is hazardous in a car? Battery, of course. Then liquids. What liquids? Fuel, oil, antifreeze, yes, cooling liquids. You need also to remove hazardous compounds. Those are not even very hazardous. They are hazardous for nature, but in cars you have parts that are deadly for person. Electronics you can't get; it's too hidden. Catalysator, it's precious metals. Tires, boring, but you have to do it because it's producer responsibility. Yes. But what is dangerous for life in a car? For instance, the airbag, because it has an explosive inside. And the point is to take a car and shred it. It is technically very easy. And as an end result, you will get different heaps. And this explosive, this thingy, is here. For this shredding equipment, it's a piece of cake. But what if you take it and then it explodes? So how many airbags are in the car? We don't know. A recycler, they don't know. We have to ask the producer because they know. Can be a very big issue if you have a lot of tires. And then you can try to shred them into powder, remove metal and textile. It's technically possible, heavily costly, and you will never do it if you can't sell this material that you produce. Because to handle a tire, every tire costs money. It's depending on how much tires you have in the country, and you know exactly how much money you need. You ask the people. When I buy a new tire, I already pay deposit. But the issue is with tires that are coming from outside this system. Then I don't pay for that. And all those tires end up in the tire recycling company. And they don't have funds for that. And also, if I buy a car from another country, it comes with a minimum 4 tires. And those tires are not paid. So if there is a lot of tires, then you can develop some recycling system. If not, then one option is to burn it. Or what we do here in Estonia, we do pyrolysis. We make oil out of tires because we have oil shale industry, which is capable of producing oil from oil shale. And if you add about 10% of tires, technology allows accepting tires. We should try to be as high as possible in waste hierarchy. So material recycling first, and only then we burn them. In recycling centers, you need to sell bricks and stuff. What do you think about that? Australia.
Yes.
Come to the shop, buy. Here in Estonia, I think it's not Estonian issue, it's a European issue. All this material, brand new, pictures from landfills, not possible to give it even for free. Too bad. You can't take anything. Or you have to build a daughter recycling center before entering the landfill. Then it is okay. Producer responsibility tells you are the producer. You as a producer, you take responsibility. Many times we use material like old car. I drive a few years, then I sell it to you. Then you sell it to her, then she's selling it to him. You dispose this car, and you are the guilty. You pay all the price. I got all the pleasures with driving a new car, but you pay for disposal. It's not fair. And maybe we should transport this responsibility not to you, not for me, but to Mr. Volkswagen. We try to say that it is a strategy to promote integration of environmental costs associated through the whole lifestyle into the market price. So when I buy this car, it already contains the price of recycling. In the end, I paid it. When it's time to recycle, I don't take money out from my pocket. It's already there. So this sign is producer responsibility organization. We have the packaging excise, which more or less is packaging tax. You want to sell a package, a bottle, you sell what's inside and you put a little bit of money in deposit as a bottle. Then you collect it back, you get money back. If there are a lot of packages on the market, it makes it impossible that the producer is collecting his own packaging If he can't collect it itself, he is delegating this obligation to the organization, which is in purpose to manage these producer responsibility funds. Now the waste is collected. Now we should treat it. It's not only to collect, it's to collect and treat. Now the producer responsible organization has two options. Recycle it by itself or give this obligation to the waste company. So, for instance, Mr. Epson has made a deal that the producer responsible organization here in Estonia is collecting a certain amount of Epsons. And then the producer responsibility WEEE Recycling organization has two options: to dismantle this himself or to give it away to waste company. Do it for me. Now we sort waste. Easy way is manual sorting. I think it's more or less existing in most countries. The same sorting line in 5 to 10 years looks like this. People who have used to work, they retire. And even if it's realistic to have some people here sorting in the future, it is no way that we can achieve the circular economy targets by just hand wash sorting. Manual sorting has some benefits. Equipment, machine, sensor-based sorting is a big step, and this seems to be dominating already now in Europe. And what new is on the market is robotic sorting, and I think it is a combination of everything. And most likely between those is what we select today. Energy. Now we burn everything. Number of plants, 70% in Europe, in Asia. 24% in Europe, 5% in America, and then it's nothing in Africa, nothing in South America, nothing in Australia, nearly nothing. Why do they burn so much in Asia? First of all, what is Asia? Japan. They have nearly all of the global incinerators in Japan. Then Korea has a lot. China is building huge amount every year. So those three. And now where is the global marine pollution coming? China disappearing soon because they incinerate a lot in the future. Philippines, Indonesia, countries like that, they are not here. So incineration from that point of view is very positive. Because it gives volume reduction, 90%. You have 1 cubic meter after incinerated, 100 liters. Mass reduction, 75%. You have 1 ton. After incineration, 250 kilos. Waste stabilizes easily. All waste can be incinerated. It's alternative energy. Heat you can use. Available as fuel. Fast. It's negative because gases are bad. Ash still remains. It has to be disposed. Material is lost for recycling. It's costly, very costly. Large scale, which in our terminology means feed the monster. Dioxins. You panic. You're afraid of dioxins. Understood in 80s, end of 80s. Study was made to see where is it coming, the dioxins. It was understood that indeed most was coming from waste incinerator. But the incinerators now had two options: either shut down or fix it. Then the incinerators started a massive scientific research. Where do they come from? And then we understood that dioxins are coming from chlorine-containing waste, like PVCs, under a certain temperature regime, which is 300 to 500 degrees is the worst case scenario. That's why now we incinerate way higher. And now, the next study says that we can't blame anymore the incinerators. The biggest source of dioxin nowadays is this. What's that? Your personal garden fire. So we blame incinerators and we personally act wrong. Refuse derived fuels. This is what smells here. Now we need to open them at the back. It's a delivery from the landfill here. What do you prefer, fresh or old? Maybe we take old.
The old one.
Let's take old first.
Old means that it has maybe it has been stored already some time.
The grand opening.
Before opening. What the hell is that? Refuse derived fuel. It's a fuel that we make from municipal waste. It has many names. RDF, refuse-derived fuel, is a general name for everything that we produce from waste, every fuel. Solid recovered fuel is something that is produced under standard. It meets the standard. So if I sell it to someone, I can say it meets the standard. Calorific value is higher, ash content lower. It is possible to prepare on demand if necessary. You can produce, and this is important, you can produce it in any island in Philippines and then transport once per year to the better place. Make it, bring it in big heaps and you get better price. So you can sell it if you are a good businessman. It is not original fuel, it's still waste. And we still lose material if we burn it. Production of this costs money. It is still considered waste as by law, so you can't incinerate it in your home open. Flue gas is still hard. Typical customer is the cement industry, like here in Estonia in Kunda. It's a multi-burner for cement industry, and we take this material, this fluffy material, and we blow it into cement kiln. Why cement? Because cement production is very energy demanding. Now we replace some of the fossil fuels. Very high temperature in cement kiln, 1400 plus, compared to 850 in normal incinerator. It's double. Very long retention time because tube is very long and gases go from one end to the other very long time. Alkaline environment, no ashes. Ash remains inside cement, which is positive. So, the waste from Tartu, and you need to have some processing. Very simple, you shred it, you sieve out the fine fraction, the powder-like, soil-like fraction, we don't want it. And all the rest, we shred it once again, remove all the metals, dry it, and that's it. What do we do with it? We try to reflect it in our university. Because the customer who is going to accept it wanted to try the briquettes. So this can be one option what to do with a massive amount of mixed waste. If you have a cement industry or a similar, very much energy demanding industry available. If not, what is in the neighborhood? Because you can take this material from one country to the other. Maybe more fumes. Nice.